to proglangcast. This is episode 7. Christopher Augustus is my name.
I'm Steve Thames.
And today's programming language is the single letter J. Ken Iverson, the creator of APL, went on later to create J. He was joined by Roger Hui, the implementer of the interpreter. Most of the information I have about J I discovered from the ArrayCast, of course. Prior to that, you and I knew about APL. Yeah. I don't think we knew about any other array languages, right? Had you ever heard of anything else?
No. To me, it looks painful. And
painful.
Oh
wow.
Yeah, it does look painful.
But
APL was painful. Is if somebody handed me a program and said, "This has got a bug, fix it," and they handed me APL, I'd be like, "Oh."
Well, I'm going to suggest. Okay. Hold your thought for a little bit till the end here. Okay. Give it a chance because...
that's what I was going to say.
Yeah.
I'm looking forward to getting your feedback on it because I know that's just a first impression and I want to be more open.
Let's take a look at where J comes from. Mm-hmm. So they have a GitHub site, but I don't believe that's where the main software is hosted. It's kind of mirrored over here. They have the source code, the J interpreter, the J language, and it is an interpreted dynamic language in the same fashion as APL. You can see it's written, interpret itself is written mostly in C. There's some J code in there, a lot of examples, some of the actual like the standard libraries in J, and we'll talk about that in a minute. But one of the things you'll notice here, Henry Rich, he is now the coder of the interpreter. He's essentially took it over from Roger Hui, the original writer of the interpreter. And those are great ArrayCast episodes. There's 5 of them specifically with Henry Rich on them. And I will put links down below to all of those. There's a lot of good information about J. Over the last week, I've just been re-listening over and over, trying to get every little tidbit of information I can and understanding a little insight into language from the people that are chiefly responsible for it. I believe Henry has said that if someone makes contributions here, they will get submitted to the master source, wherever that is. So they do take contributions for it. And it continues to be worked on. I don't know the exact size of the community, but there seem to be quite a lot of people around that use it. Their official site, of course, is Jsoftware. On their site, we get an overview. If you go to documentation from here, the JWiki. There's getting started, beginners, there's all this sort of stuff. It's everything you need to know to talk about it. The one go-to is this NuVoc. And this is where you can see the essential syntax in the array and the primitives and what they mean and dig down deep into them.
Yeah.
There's a lot of primitives. Now, what I've learned is that the old APL was a lot more limited than the modern APLs like Dialog. And what happened is J, because it was essentially APL 2 for Ken and Roger, and Roger actually worked at Dialog. So they both worked on APL and J, and that J developed some innovations that then APLs later adopted. So J was the first to do certain things, and then Dialog APLs and maybe some of the other APLs took those and brought them into APL using APL glyphs instead of the J glyphs. It's a big language. It's got a lot of capabilities, a lot of features, and it's evolved over a long period of time. There's a standard library, and there's a lot more stuff going on here. We'll come back to that. Oh, but the other thing to know is there is a playground. So remember, for APL, there's a tryapl.org that's put up by Dialog. This is the J playground. J, just like APL, it's an interactive. There's a repl here. Yeah. They've got samples. They've got labs that go very deep into what you can do. Keep in mind that the array languages, and particularly J, are really focused in the mathematical and scientific sphere. In fact, one of the strengths of this language in particular is its ability to deal with numbers, like all the exotic complex numbers and types of numbers that go into like really deep math. I think even more than any of the other array languages. Math seems to be a very big focus of this. But I actually used a lot of this to try to work out some issues I was having figuring out the syntax. You can see I was kind of struggling with various things here, and I did use the J Playground, and this is available to everybody out there. What we're looking at is a screen of source. How many lines do we have here? 11 lines for Bye Bye Hello World, and it is just all symbolic characters. The only words we can actually find in here are the strings that are presented to the
Quoted.
screen. So world
The
hello,
quoted ones.
countdown. There's a main to flag the
Main,
body of
you
the
sleep,
code.
and argv.
And of course,
Right.
the top line is the shebang for the shell. There are 4 variations here.
Right.
I took inspiration from Adam's work on the dialogue APL versions of Bye Bye Hello World. Remember how he came up with 4 variations, and he showed
Yeah.
gradually degrees of more and more tacit, and tacit means you remove arguments are implied, you remove intermediate variables, fewer expressions, an expression where everything kind of collapses in. This is the most tacit version, so it's actually called BBHW-tacit.ijs. The main variation looks a little more readable. I'm going to click to that so we can see that. Okay, so this is what I'm considering the primary.
Interesting.
It's just BBHW.ijs. Everything else is going to be a variation. It's going to be a variation on this. The goal here is to make this one the most idiomatic, meaning what the J community, J people, J experts would think would be the right way to write this kind of program. I haven't verified that with anybody other than Adam, and Adam, he'll tell you himself he's an APLer. He's barely a Jer, but he knows a lot more about J than I do, obviously, and I'm sure his knowledge is more than he probably claims. But we went back and forth today on Discord. He was suggesting he tuned it up quite a bit. He got rid of some redundancies and stuff, so this is a nicer, cleaner version. In fact, when Adam did his 4 variations, one of his variations he called balanced. And I just asked him in Discord, I said, I'd like to pick one of those to be the bona fide one that you think is most idiomatic in APL. And he came back and he said the balanced one. But I want to show you 2 of the alternates, because the tacit one that you just saw is an alternate. I think even Henry Rich and other people will say, if you try to go, completely to the wall with tacit, which is what I did, it's extreme. Like, you shouldn't go that far. You don't gain anything by doing it, even though you can kind of pull it off. It's more like a code golf thing. We'll come back to the tacit one, but what I want to show you is this is the balanced one, or the idiomatic one from my point of view, and I'm happy to have people correct and come in and say, no, an idiomatic way to do some of these things you've done should be like this. I'm hoping people can do that, and we'll change the code. All the stuff in our repo for BBHW is subject to people contributing who know way more about these languages or are steeped in using them and understand the idioms better to say, this is the way this should be written, and we really want to see that happen. But let me show you the other 2 variations. This one's called wordy. So it's structurally the same. It's a single procedure, main. It does all the same things, but you notice how many more words we have here instead of symbols.
Yes. It's very imperative.
These are cute. This is purely procedural. It's the most wordy version, and also it has the most white space between symbols, so you can kind of separately identify the individual glyphs. Although technically I could define my own words for symbols, and I could DSL this thing so that there are no symbols in there and it would be just nothing but words. Could do that. But these are words that are built in to J itself. I didn't use anything that wasn't, other than the main. The main is a declaration, obviously, that we made, but everything else is predefined in J. So the other version is a more functional version using what they call explicit definitions. And this is similar to some of the work you did in F# and elsewhere, where instead of a single structured version, separate functions have been broken out. So if you have a name and you say verb define, there's explicit definitions here. And I just kind of broke this out into individual ones. So this being the most lines, it's the longest, it's the most subdivided. It's fairly wordy. It's somewhat functional. It's a little more functional, a little less procedural. Actually, let's go to NuVoc. This is the list. Remember, this is the vocabulary of J. This shows us all the glyphs. J is really 2 languages. And I think this is actually true for a lot of programming languages as I started to think about it. The language that we program in and the language people use to describe the language that we program in, they decided to call the semantic aspects of the language in a unique way. So instead of saying functions, they say verbs.
Verbs. That's what I was going to ask.
Instead of saying values, they say nouns. instead of saying what is often called a modifier in functional world, they call it an adverb if it modifies one side of a verb, and they call it a conjunction if it's between two verbs. They decided, let's go with English grammatical terms. I've never heard any part of in a programming language ever describe a procedure, a function, a subroutine as a verb. Have you?
Not that I recall.
Right.
No.
If you scroll down here, you're going to see at the bottom of vocabulary is a vocabulary for what I'm calling the second language, the language used to describe J, the programming language. A direct definition. Well, in other languages, it's a lambda. In APL, it's a defense. They decide to call it
A direct definition.
what is sometimes more common terms shared across other languages. But this is true even in modern languages. I've noticed that, for example, in Swift. Suddenly they'll decide, we're not going to use this term everyone else uses, we're going to call it something else. Almost like the grammars of programming language are described from a branding point of view. Now, that may be unfair. I mean, I think from the basis of the language designer, I could see them going, I can't really call it that because even though it's that in that language, in our language, it's different. And so we're going to give it this new name as to not confuse people. So the reason I bring that up is you see right here, verb define.
Right. That was the first thing I was going to ask about.
What's a verb?
So you're defining a function or a verb there, and it's the main one. So is J the same way? It looks for main to know where to start
not at
running,
all.
or
So this is
so
the
it's
name that
scripted.
I gave it. The green, like TM output, that's a standard library word. The ones in white are identifiers that the programmer, in this case me, I've created. Verbs are procedures. Oh, and also the other term they use is sentence. So a sentence is, in other languages, statement. The sentence begins at the beginning of the line, it ends at the end of the line, unless it's within some kind of block thing, like the two braces that open and two braces that close a direct definition. Then you can actually wrap. But if you don't have a block like that, then you have to complete everything you're doing on a single line. It goes top down, sentence at a time, and each sentence is parsed on the right side, going leftward, executing leftward.
But J is left to right.
No, J is right to left, just like APL.
Really? So if I read it right to left, what am I reading?
These two quotes are empty. It's a literal.
Can that be applied to any variable or any?
Yes. So
Okay.
J again, like APL, it's a dynamically typed language.
Got it.
There's some type enforcement that happens under the covers at runtime. There's no type analysis. There's no type specification other than the inference that the interpreter does that you put something in quotes. It's a string. You put digits in there. It's going to treat it as a number. There are no Booleans. Booleans are 0 and 1, just like APL. They're numbers. If you have a string, it's in single quotes. If you want two single quotes in a string, you repeat the two single quotes within other quotes. You'll see there's some code there where there's like 4 single quotes lined up to get a certain number of quotes mashed together. The double quote is used as part of the glyph syntax for specific glyphs, and you'll see that.
Okay.
Oh, and I should mention, of course, one of the big distinctions in the symbols used by J versus the symbols used by APL, J restricts itself to the 7-bit ASCII code set for symbols, aka the symbols you're going to find on most keyboards that people can simply type directly in. It doesn't require any special Unicode code points like you would need for APL or for BQN. So I have really mixed feelings about it because I find the ability to read and see and cognize what a symbol is doing in APL and BQN is so much easier because they're very unique and they're very nice looking to my eyes. But because J is restricted to the short number of symbols, they actually put 2 of them together a lot. A single glyph is sometimes made up of 2 symbols next to each other, and they call it a digraph, like two characters together to mean a single thing. Sometimes they're single characters, and sometimes they're double. Now, so we start with that. We get a list of nothing.
And the left angle bracket is?
The left angle bracket, this is a single glyph, and it's the less than sign or left angle bracket. Arrays can contain other arrays, right? So you can have an array of nothing but scalar values, but you can also put arrays inside arrays.
Sure.
And in order to do that, or to have an array of mixed types, so let's say you have an array of numbers. They're all the same type. Now, we don't specify the type, but if we put a bunch of numbers, we get an array of numbers. If we put a bunch of strings and we strand them together, we get an array of strings. In fact, a string is an array of characters, so it's inherently array. But if you want to mix types, like say you want to have an array in which the head of the array is a number and the second part of the array is a string, J doesn't allow that directly. It doesn't allow you to mix types within an array. What you have to do is you have to contain them within their own little container they call a box. So you can put anything inside a box, and then you can have an array of boxes. No matter how many dimensions your array has, you can have up to 64 dimensions array. It's like crazy. But ultimately, you boil down to the elements of an array are ultimately, the final elements are scalars. Now, if you want to put something inside that scalar, you make a box, and then it can have a whole nother 64 element if you wanted to, and then you could go infinity. But a box is a scalar, a number by itself is a scalar. The comma means append. So it's going to create an array.
Empty value, create a box, and append.
It's going to take a box. It's going to append it to something else. The only thing that we can legally append a box to is another box. It turns out that argv, when you get arguments from the command line, they're boxed. Let's bring up the shell. We just want the idiomatic version. There we go. Let's actually run it. So I'm going to do just run. Oh, by the way, I don't know if we want to look at, we don't really need to see this, but you can see we're calling up JConsole. JConsole is the REPL. It's the console. It's the workspace at the command line. There are many different user interfaces for J. I didn't experiment with any of the others. There's a graphical Qt one and all that sort of stuff. I just dealt with the console one for Bye-Bye Hello World. So we're just going to run it with no arguments. And we're going to see, because we didn't give it any arguments, it says, give me a countdown. So we prints out countdown, colon, it's waiting for input, right? If I say 0, I want no countdown, I press enter. It prints out world, hello, .. There's no countdown, bye immediately, right? Okay, let's do run again. No arguments this time. And now I'm going to say 1. I get world, hello, 1, bye. I don't know.
That's interesting.
I don't know if you noticed anything in there. Let's see if you.
It didn't appear to be any delay.
Well, let's try run again, but this time I'm going to put in 3. Watch what happens.
It's not outputting anything until the end.
I do have comments in these source files. I took them out for the sake of this presentation. I'm going to put them back in. This comment down here, see the to-do? We count out each second and we do a delay.
Sure.
We want to see each second as it's counted out, right? So we start out that, and all of our programs should do that. That's part of the spec of Bye-Bye Hello World. But some of the standard outputs get buffered, and they won't flush by just repeating outputs until something happens, like you do another input or you do a end of line. We don't want to do an end of line because we're appending each second to the next second with the 3 dots in between. Run this same exact source under the J interpreter on Windows, it flushes, and I do see each character. So this is a gap on Mac OS. I went through the C code to see how this stuff was implemented, particularly for these problems. So I spent some time looking at their C code. It's written in C. It's typical C in that there's platform-specific wrappers, right? Preprocessors for specific platforms when they can't do what they need to do through the C standard library and straightforward C. And I/O is one of those places where there's a lot of friction, right? Depending on the platform. The actual J code that puts out each second in Windows works properly, and I get the sense that most people use it in Windows. The array languages are end-user software, right? It's software used by people trying to solve scientific, mathematical, financial problems, typically code written by domain experts that are just learning the language. The early APLs, the early things, they're Windows, DOS, then Windows, and then only
Yeah.
recently Linux and Mac OS. Back to the command line, we're going to do run, we're going to do a typical thing. We're going to enter something that's not valid, like let's say cat. It says, oh, cat's no good. Let's say dog. Okay, dog's not good either. Okay, let's say 0.
How about -1?
We're already trying to break it.
Well, that's okay. I'll explain why. Wow, is that what you intended?
I did not test for this. It took me enough time just to get through.
I know.
Basically,
guess
getting it
what?
working.
Remember, I told you when I was working on Erlang, I found a bug in F#. That's what I found. Except that mine didn't continue running. It just didn't give you the error messages. It just asked you for the countdown again.
By the way, that's how -1 is represented in J, with an _1. Because otherwise, it would be minus, which is the minus verb. No more trying to break it. Let's just do normally. So we're going to give it an argument. This time we're going to say 0 at the beginning. So it doesn't ask us. It runs through it. We'll give it the argument 1 because we don't want to wait to see the delay. There's the 1. We'll give it the argument frog. It doesn't like frog. We'll say Fred. It doesn't like that. We'll do 0 and get out. Okay. I'm just going to output at the very beginning here. There's a keyword, as you saw in the, you can in the wordy version called MS output, SM output. This is in the standard library. Notice you don't see that anywhere else in here, and I'll get to that in a minute. But let's just see what argv looks like. Let's say frog, dog, cat, fly. Under J here, they're just like, if it's a box, we're going to show you a box. So this is an array. What we're seeing here is an array of 1, 2, 3, 4, 5, 6 boxed items. And in fact, if I mix my types here, I think it's going to treat them as strings though. So let's say frog 1, -5, dog. It's still, these come in as strings.
Yeah,
and they're stuck into boxes. So back to the source code. This is a shortcut that Adam said, where I remember I had the single quotes and I had the put it in a box. The enclose puts it in a box. This is an empty box. So a : is automatically an empty box. I guess it's idiomatically used so many times to use empty boxes that you just said, we'll just make a symbol for that. And this is an example to me where a language grows beyond where it needs to.
All right, show me what it looks like.
Let's see what it looks like. So I'm just going to show you that part of the expression. Let's do this as well, right?
All right.
So there's your a : your empty box. There's your entire argv, and this is the append of the empty box on the right side of that. And let's run that.
Okay, so we're seeing the empty box, and then we're seeing argv, and now we're seeing
argv with
an
an
empty box appended to argv.
Yeah.
So then you have the brace and the 2, and I'm assuming the right angle bracket means something similar to the left angle bracket?
Well, let's find out. I'm going to do this.
You're missing a right angle bracket.
We're going to see what that does.
Well, what's the right angle bracket?
So APL is indexing is 1 based. J's indexing is 0 based.
The 2 brace.
Yeah.
Is that specific to an array?
It expects the argument on the right to be an array, and the argument on the left in this case is an index into the array. This is literally give me the element of the array.
And in the J console, you already know that elements 0 and 1 are going to be J console followed by the name of the script.
Correct.
And then so all you're doing here is you're just appending an empty box to argv to normalize it so that you can access 2 and find out if it's empty or not.
Right. So I'm going to show you why we need the box. I'm going to keep the parameters there for a reason. Watch. Okay. So we still get the frog, right? No problem. But if we put in no parameters, what do you think is going to happen?
Some kind of an error, I would assume.
When it gets an error, it doesn't do anything but just terminate. It doesn't display the error in the J console. If I code this in the playground, or if I go into the J console directly, if you try to access an element of the array that doesn't exist, it doesn't give you nothing. It gives you an error.
Yeah.
That's why I append the empty box. So I guarantee I'll always have an element in that position. Getting an empty box is fine. I get an empty box, but that's the whole reason. I had to do this in GNU APL as well. What do you think this right-hand bracket's going to do? Okay. Now that I have the box, the frog in the box, frogs in the box, what's this going to do? If you had to guess. He's thinking.
Converted from a box to a value, maybe?
Wow, dude. I think you're becoming an expert.
The frog jumps out of the box.
Yeah, the frog came out of the box. Language design is hard, and these people know what they're doing, and there is a lot of thought that goes into what is the right symbol that we should use. What's the right combination of symbols? I mean, remember when Adam's interview, he talked about how important it was to get the symbols right. I mean, to other people look at it and just go, these are crazy symbols. I can't read them. I don't know what they are. And he's like, no, we sit down, we think a lot about the shape and the curvature. The whole thought of visual design goes into it and all sort of stuff. And he gave us the example of the stencil. He's like, it looks like a stencil. And it's elegant because it's able to reuse the diamond and the quad. And it's kind of perfect. It's like the stars aligned to come up with the symbol. They put thought into this. They're like, okay, put things in a box. We'll make it so it looks like we're boxing something, and then like we're closing it in the box, right? It's kind of clamping down on the thing on the right, and then it's opening the box. If you think about it, right? This is putting you in the box. This is opening the box. And they've only got so many symbols to work with, so they end up reusing the left angle and the right angle bracket in combination with colons and dots to mean something else. But by itself, they've decided it means put it in the box, it means open it from the box. There's some symmetry there.
In the wordy version, you had the left angle bracket.
I think I fixed the wordy version. I think it was the explicit version. Because actually, that's a really good point.
Well, I noticed it because you're using the primitive on the one side, but is there not a primitive? And the truth is, I would prefer seeing this.
No, I agree
for this
with you.
kind of a line.
I agree with you
this.
Because remember, I was saying, Adam pointed out to me. He said, "Well, instead of doing the left angle bracket and the two quotes to create an empty box, we've got this nice primitive a colon. They call it ace. The name is ace. I haven't deep looked at it. There may be another use for it, but you're right. I look at that and I can see, okay." This thing is grabbing and putting it in the box, and on the other end, I'm taking it out. You can almost visually see like it's going through a process, it's going through a pipeline here, going into a box, picking pieces out, and then pulling that. And so there's a nice symmetry there. I agree with you. I like the way this looks better. Let's ask Bob about that when we talk to him. I don't know the history of why they created the a colon. But maybe somebody thought, oh, this will be convenient. And in the process of adding and growing the language to add new conveniences, and maybe in this case, you take something away.
Now, the equals period, is that an assignment?
That is. It's an assignment to a local variable.
Are the variables mutable?
Variables are mutable. There's no immutable variable. The comments then they were talking about mutation. I tried to come up with a readable version that had no mutation. The only way I could do it was making that crazy tacit thing.
But the equals colon, is that another assignment?
The assignment is to a global variable. They call it is.
Okay.
So that's is global, and where count equals dot, that's is local.
What's 3:0?
Okay, good question. When you look at the wordy version, it's verb defined. Most of the words are convenient aliases for things that are done by symbols. So I get the impression that J was originally all symbols for all of its primitives. It didn't have any words for primitives. Like the while, the do, the end, the you sleep. These were added later on. And I get the sense they were added as a convenience.
Can we take a look at that one real quick? The shortest one?
The crazy compressed, this one.
This one, the tacit one.
By the way, I posted this on Discord the other day. And the Dom was the first to come back privately and say, wow, what did he say?
Sucks.
No?
He didn't.
He's such a great guy.
He's a nice guy. I'm translating.
He's a super nice guy. No, he said, ooh, Not very elegant.
Yes, yes, that's what it was. I loved that. That was awesome.
Not very elegant.
That's what I mean.
Yeah.
That means it sucks, Christopher.
That means it is ugly. That thing is butt ugly. Yeah.
Yep.
And that started our whole conversation today because I
Translate
said, yeah, it's messy. And then he's coming back and forth. And I said, okay, here's something maybe is a little more readable. So yeah, that was fun. And this isn't finished. I think this could be made more tacit, believe it or not.
Oh God, really?
Well,
more agonizing.
Well, Adam did his one-liner APL. It's
I
very
know.
dense. He's got a couple defense in there. He's got a couple of built-in defense, but there's a way to get rid of the defense so that even these Ys go away. You don't even see the Ys because those Ys are actually arguments.
Well, and with all due respect to Adam, and I have a great amount of respect for his knowledge of APL, I do not see the value in one long line.
Well,
of
he
symbols,
doesn't either. He doesn't either. He's like, yeah, I wouldn't do this that way. That's why he said this is the balanced way would be the nice way to do it. He's just code golf, If you want to do it on a single line, we can do it, and here's how you do it. I think it's cool. I mean, you're right. I don't want to write all my code like that, maybe.
Yeah, I don't have to, because I don't want to have to scroll that far to the right.
But I did a couple of things in here. One, I compressed it to get rid of all the white space other than what was totally required, except for the indentation.
Some of the symbols I'm recognizing here.
Yeah.
Okay, I'm starting to.
Well, there's only a certain number of characters available. Although they get overloaded big time. So like the colon dot are overloaded on everything. They're like augmenters to change the meaning of stuff. But yeah, let's go back here.
Now we're doing a while loop, and just a question there.
Yeah.
What is the significance of the period? I'm noticing while period and do period. Is that signifying the end of a verb, or what's the purpose of it?
That's just the syntax of those primitives. The primitive while is while dot. If I get rid of
Just
the
while
dot,
dot.
it's not
Okay.
while. If you look at the NuVoc for all the control flows, they'll have dot. Maybe period is not legal for user identifiers, so we wanted to make sure it doesn't clash. See, this is an example of where I'm speculating. It's possible this was added to the language later. And one of the problems with all languages is it's easy to add. It's hard, if not impossible, to take things away. And what maybe happened is they added later these keywords, but if somebody made their own while in their code and they made while a reserved word, it would break their code. So
Does that mean you could have while as a value?
Well, if I get rid of the dot, it becomes a user identifier.
Oh, so you can actually do that. Okay.
Sure.
Curious.
Because there are no reserved words. And in fact, I think probably what happened is they added while later, and to make it reserved, I bet that dot makes it not legal as a user identifier.
While hashtag count is not a valid number or something like that, or is not recognized as a number, or
So
what does the hashtag mean?
Tally. It's length. Give me the length of the whatever it
Oh,
is.
got it. Again, so everything is lists.
Well, everything's
Let's
an
say,
array.
for instance, if you took right. So pound, the hashtag means the length of it, length of count.
It's a length of whatever's on the right. Yeah.
And I'm going to say input is equal to, now this is the expression thing you were talking about. You've got the two
Left braces are the beginning of a direct definition.
Right. So that's a direct definition. And then we're saying,
which is a lambda. This is the one case in which I can wrap a single sentence on multiple lines. So if I did it on a single line, it should really read like this.
Yeah.
Because I have a blocking structure, I have the ability to break this into two lines, and it'll still evaluate at the end, starting from the end of the second line. Whereas if I just have two sentences, it doesn't do that, right? If I have two sentences in a block structure.
So what you're saying is NB period dot local mutation is where that sentence ends.
Exactly. So it starts on the second line and walks backwards past the new line to the line before it in terms of interpretation.
So I'm saying here that on the end of that sentence, I'm saying, so input, and then I've got an expression here, direct definition, 0 is equal to the length of y, which doesn't have a value yet. Does that define y?
All verbs have either one argument or two arguments. They have an arity. The arity of a function, in this case, they either take, some languages actually have the ability to take 0. They call it nil-adic. J does not have nil-adic. It's either monadic, or in Latin, it's unary, or it's dyadic, which is Greek. In Latin, it's binary. The right argument is always given y, and the left argument, if there's a left argument, is given x. X is optional. So y, all verbs have to take at least a y, and they optionally can take an x on the left of them. In APL, the right argument is omega. It's the little omega symbol, the little w. The left argument, which is optional, is alpha. In BQN, the right argument is the doubled x.
Yeah.
And the left argument is the double W. So all three languages decide alpha, omega, XY, WX. They could not agree with each other on what to name those exact.
Well, you know, maybe it's that whole, I have to have something different than
well,
that.
I would say J is the closest to the math x plus y, x squared plus y squared.
That direct definition then, input is coming in as y.
Exactly. Whatever's on the right inside the direct definition can be represented as y. And that's why direct definitions and defends and lambdas are not truly tacit.
Where would x be? Would x be on the left of the definition?
Okay, let's just put it on a separate line by itself. Let's say our sentence is just that. So our sentence begins with the direct definition on the left.
Right.
It ends with input on the right. It's evaluated from right to left.
Right.
You can think of the entire direct definition as a single verb. It's equivalent to a single primitive that's built in.
Sure. Yeah.
Except this is a primitive or a verb that we've constructed without giving it a name, and that's what makes it direct. Explicit means you've named it. Direct is lambda, unnamed, or also known as an anonymous procedure, anonymous function. So this sentence really is a verb and a noun.
And it comes in as y.
So inside the verb, its use of the argument coming from the right is represented by y. There is no x here. And because there is no x here, there's no argument on the left. That means this is a monadic definition.
So are you saying then that if there was an x in there,
if we could put the value,
we could put the value.
If I put 0 right there, or I put hey, then I now have an x available inside that direct function.
Do you have an x because hey is the value is there, or do you have an x because there's an x inside the direct definition?
Jay will throw an error at me saying that's not a valid expression.
Because x is not in the direct definition.
Because I never referenced x.
Right.
Most of these primitives are what they call ambivalent or ambivalent, or they have ambivalence, meaning these two symbols or single symbols have two different purposes depending on if they're monadic or dyadic. If they're used monadically, they do one thing, and if they're used dyadically, they may do something entirely different.
Okay.
Now, they try to make it so that there's some logical correlation between the dyadic use and the monadic use, but it's a way that they overload the use of symbols. This happens in APL, it happens in BQN, and it happens in J. You can't do something on just the left, by the way. The only option is right only have an and left, but you can't do just left. Now we're inside the direct definition. We're gonna execute it right to left. Y's length is equal to 0. So I'm going from right to left.
Got it.
And depending on how things are ordered, you can end up with a monadic operation followed by another and its result feeds another monadic operation. That's a composition, right? So the result of that is the input to the next, and the result of that's the input to the next. But then sometimes that'll feed into something that has something on the left, and so that becomes the right argument, and the thing to the left of it's the dyadic. So what you can end up happening is you can have a monadic followed by a dyadic that becomes a monadic, becomes a dyadic, that's another dyadic. And so when you're reading, you can't really tell from the left side what's going on until you follow from the right side.
If you think of this in terms of a stack-based operation, right? You would pop off input and replace it with the length of input, and then pop that off and say, is it 0? Then you pop that off and put 0. So so it starts with input, then it becomes length of input, then it becomes 0. If we're reading right to left, and now we have a 0. 0 is equal to the length of y. So I'm assuming that that's some kind of a comparative.
It is.
Because you said there are no Booleans in this language. There's either 0 or 1.
Correct.
What I'm looking at here appears to be something like a Boolean condition. What's the caret colon mean?
Okay. The caret colon is the power primitive.
You mean exponents?
Kind of. APL and all three of the languages that I'm so far familiar with have this power primitive. Whatever you're doing on the left, power, repeat this many times on the right.
You don't mean as an exponent then, right? I mean, it sounds like you're saying repeat.
Powering or doing a square or a cube is the same thing. It's saying multiply this many times. So square means multiply twice. Cube means multiply 3 times. The thing on the left has to be a verb. It's not a noun. It's an action to take and a value on the right that tells me how many times to take this action on whatever thing you're operating on.
Just the fact that countdown is there in a string does not put it to output, right?
Correct.
I'm assuming that the 2 & 4 has something to do with that.
Okay, so the difference between running in a script and running in the repl, if I go into the J playground and I put countdown in, it'll go countdown. So whatever the result, actually the way the repl works is it executes whatever you enter, right, one sentence at a time.
Yeah.
It always gives you the result. So the result of a value is the value.
Sure.
When we run it in a script mode, it suppresses the output of the results of sentences. So the only way to get it output is to tell it, is to do a system output operation. The 1 bang colon 2 and 4 is a sequence that says output to standard out without a new line.
You're kidding. Really?
No, I'm not kidding.
Okay.
Let's go to the wordy version. TM output is an alias for that string of characters, which is 1 bang colon
2 & 4. 1 bang. Yeah.
ampersand 4. Because,
Okay, so,
because
but-
those things are so obscure, I think they came up with these aliases for things like, so SM output will put a new line and TM output will not put a new line.
Got it.
So they
Okay,
do
so
have that
the
variation.
bang colon is a primitive though.
The bang colon is a glyph they call foreigns. Things that you need to do that aren't part of just the primitive algorithmic stuff in J are foreigns. BQN, these are system functions. In APL, they're quad somethings. They call them foreigns. M is like a grouping. N is like a subgroup. And then you pass it arguments. And here's what it looks like. Let's go to files.
Wow.
There it is right there. M is 1. N is 2 says a 4 means go to standard out.
Right up to this point, everything was fun. We were just playing with different symbols, what they mean.
I think they.
This just got painful.
I think they have a sense of that because they call them foreigns. Sometimes you got to do I/O and read from files and things like that. And instead of contaminating the kind of mathematical purity of the core language, it almost feels like we're going to put this in its own category. And again, I get the feeling that the early incarnations of J, incarnations in flowers, incarnations of J, wanted to avoid keywords at all costs. And so they group things with these numbers. Notice the wordy version? It's not completely eliminated because they only made aliases for some of these things. The standard library for TM out is nothing but a defined TM out is equal to that.
Well, you know what, you don't have I don't think you have a problem with it really, as long as you're going to have a cheat card sitting right next to you. Well, you're not going to remember them. You know, there's no way.
It's just like anything. You use something often enough, and eventually it starts to sink in, right?
Well, except that SM output and TM output are things you have a much more likelihood of remembering.
If you speak English.
Than was it number 1 or number 2 or number 3? In the case of up on your input line, you're saying, give me the second element, the second box in this list of boxes. That's very, very clear. It's the number 2. It's the second one. The count's length is 0. You're saying 0. That's a number that represents it. When you get into this other thing where you're saying, how would you even say what that is? It's not a number. I'm going
to play defense for Jay here. Actually, I made the same point to Dom when we were chatting back and forth today, because he doesn't like the foreigns. He's like, I look at a foreign, I have no idea what's going on. And I'm like, yeah, I get that. But here's one advantage. Every one of these things I know is foreign because of that bang colon. If I see SM output, input, I'm not sure. What is this? Is this something I define? Is this something in the library? But it makes it stand out. It's like suddenly I'm stepping out of my nice place. And in fact, this same argument was made about the the while do constructs and stuff like that. If you'll notice in the tacit version, I figured out ways to use certain mathematical constructs to achieve what the while do does. But remember when we were talking to Adam, he said, he was talking about the CEO of Dialog was saying, no, it's appropriate to use these things that don't look like APL symbols because it should match that. It's not a transformation calculation. It literally is defining the structure of your program. If you look at the tacit thing, you can't see the forest for the trees. It's all trees. Whereas here you can see, okay, I can see where I've got some pipeline-like transformations, but here I've got just strictly control flow. Here I've got a decision, control flow.
Yeah.
It's all contained within control flow. This is kind of like this idea of functional core imperative shell, but this would be more like algorithmic core imperative control flow. Look at the standard library that has SM output, TM output. It's a J file just like this. And it does nothing but says define this as that. In fact, one of the things about J is
makes sense.
You can define all your own verbs the way you want. So you can make a full DSL with all the keywords you want, and nobody ever has to code and assemble.
What does the left bracket mean?
In APL, when you want to have more than one statement on a line, they have a diamond symbol.
Yeah.
So it allows you to combine things on a line, right?
Are you saying left bracket is doing that?
It's effectively doing that. And Jay, they say this is a way to do the diamond, but that's not really what it is, but it accomplishes the same thing. The left bracket is between two nouns. The one on the right is the result of what happened is a noun. Results are always nouns. We outputted
Countdown.
I think in this case, the result might be countdown. Without this, it's going to basically see that I've got two nouns next to each other. It's a left brace that just says, just deal with the left. I don't care about the right. Just ignore it. Drop it.
Okay. It's identifying the end of this statement. You're going to go to the left now and start reading from scratch. All right. So you have the parenthetical 1 there.
It's a parenthetical 1 because if I put a 1 by itself like this, that becomes an array. So if you just put values or nouns by spaces, it goes, oh, you're making an array of values. This is actually the right argument. This is the Y argument to the expression on
the left.
And if I don't have the 1 there,
well, okay. So
it's gonna basically say your N expression here, which is what that's supposed to be. The subgroup identifier 1 is really a 1 and a 1, which is not valid.
The 1 bang colon 1 is a foreign.
Yeah.
And its operand is the 1 that's in parentheses. The 1 on the left says files. The left
files.
of the bang, so it's okay.
Yeah.
And then
the immediate
file group 1.
This is read from file, and then
from standard in.
Not standard in this case. In this case, keyboard.
1 is keyboard.
If I do standard in, it doesn't work.
Effectively, file handle 1, which in this case is the keyboard.
Correct. Special file number. Yes.
And the reason you have to
otherwise you give it a number of a file that you've opened.
If I had 1 assigned to a noun, then I wouldn't need parentheses. Okay, so we haven't talked about the caret colon.
Yeah.
What's
power? This is a functional way to do if.
It's sort of like a coalesce. It's saying if input is empty, then do this bit where I take input from countdown, otherwise assigned to input.
Power is a dyadic primitive right now.
Right.
It has a left side and a right side. The left side of this dyadic, its argument, is required to be a verb. That direct definition is a verb.
If y's length is 0, then execute this verb on the left.
Yes.
But what happens if y's length is not 0?
Now,
nothing happens.
Notice that input is the y of this whole expression. So if it doesn't do anything, its y remains input. Okay, so here's power.
Okay. You've got an x there that's optional.
The x is optional, yes. That'll come up later. There's no x in this case because the next thing over is another verb, is a sign, or is.
So what you're saying is you take y and then you execute in, and if in ends up true, then execute u. Otherwise, use y.
And y is not only an argument to this overall expression, it's an argument to the condition. So it serves two purposes. So it only has to be expressed once. That's why I put input there. It gets used by the condition, and then if the condition fails, it also becomes the result. And in fact, I really like this. I was writing some code in Scheme 3 days ago, back to the source. And even though, because Scheme's macro ability, I could write my own macro for this, I wanted to use something without having to write my own macro. But there's so many times in which I want to say, I have a value. If a value is something, if this condition is met, use this other value, otherwise use the original value. And I want to do that tacitly. I don't want to have to say, if X is something
I get it. I'm
X,
wondering if there's a name for that.
I do not like this. Look at how many times an input is named there. 1, 2, 3, 4, 5, 6.
No, I agree.
This is cognitive overload for me. And this is,
I agree.
This is when I
using
recode,
the same, using that over and over again. I agree with that. And this is exactly what I'm talking about. A tacit approach to this would obviously be preferable. Input y's length is equal to 0. Just take the value, the y, the implicit y, and return the len. Then that'd be completely tacit, okay? Because you would never represent input. In this case, we have to do it through y because J doesn't have another way for you to get that value in there. You can't compose.
Yeah, it does. I just I haven't described it to you yet. I'm going to show you what it looks like.
In that sense, this would not be as tacit as you can get.
See that expression right there?
Yeah.
That's the same exact expression, except there's no y there.
Right.
Whatever argument.
There's also no input there.
There is. Whatever comes
No, I mean,
in,
there's no word input there.
No, but the value is coming into this expression from the right-hand side.
I see it.
This is actually called a fork.
In the other one, you couldn't have just said pound. You had to say pound y.
When you make a direct definition, you don't gain the input argument implicitly. You have to name it. And if you want the thing from the left, you have to put the X in there. And that's why if you can convert these direct definitions to parenthesized forks and hooks, which are forms of composition, then you don't need the X and Ys. And then it becomes really tacit. And I tried to do that here. I still ended up having to use direct functions. You can see them. But in more places, there are these hooks and forks. So this is a fork. Whenever there's 3 inside, it's a fork. And when there's 2 inside, it's a hook. And these are different forms of composition. It's a way of saying, take whatever argument you is, apply it to here, apply it to there, and then apply the 2 results to the thing in between.
Are you literally talking about character length, or is it like
this
a
is
primitive?
This is actually a special case of a fork because the leftmost verb is actually a constant value. It's a little bit of a special case. But for example, if I put shape, I think it's $, the pound becomes monadic. It basically says whatever comes in on the right, give me this verb of it, which is give me its length. Give me its shape, and then take the results of those 2 verbs, and those become the arguments to the dyadic verb in the middle, which is equal. So you have a typical
The
fork.
shape is equal to the length.
If I had an argument X on the left and an argument on the right, I don't, right? Because that parentheses is not a noun. So there's no argument on the left. Then instead of monadic, dyadic, it would be dyadic, dyadic. So it would take the 2 arguments, whatever that thing, the hash would be a dyadic, take the 2 arguments, the plus be dyadic, and then apply the results of those 2 to the other. It's called a train. It's like a way of saying, do this verb to those arguments, do this verb to those arguments, take the result of those 2 verbs and apply them as arguments to the 3rd verb. It's actually a combinator.
Okay, I get it.
Yeah.
That's an interesting way to.
It's a super shorthand. Yeah.
Yeah. Let's go back to the other code. I don't want to try to interpret this one right now. I still don't know exactly what to call the caret colon.
It's a power conjunction.
A dynamic if is what they're called.
Yeah.
All right.
And I decided to use that instead of the keyword because it felt more idiomatic.
X is a left-hand side that can go into the U.
It goes into the U and the V. So
it goes into both.
Yeah. It makes both of them dyadic.
And then now what about the double quote period? Somehow convert input to count.
Yes. The quote dot is format. Actually, I'm sorry, it's not format.
Is it converting it to a numeric?
This is the thing that Adam corrected me on. Remember, he said, oh, it's clever that they did this thing where they tried to figure out if a thing's a number, right, with all the digits and stuff. He says, you don't have to do that. Just take a string and pass it to the interpreter to be evaluated. And if it's a number, it'll turn it into a number. That double quote dot is do. The argument on the right is a string. Whatever that string is, do interprets it as a valid J expression and gives you a result.
And the result is a number?
If it looks like a number, if it matches, it gives you a number. If it doesn't look like a number, it doesn't give you an error. Guess what it gives you?
A string?
It gives you an empty. You get nothing. And in fact, when you use the J playground, what'll happen is usually every time you enter something, you get the next line is the output. If you get a nothing back, it doesn't make a line. It puts the carriage return right there. It's like nothing happened. It's a no-op. Yeah. Count gets assigned the nothing, and you take it into the next condition, and then loop back at the top because we're going to continue to repeat while there's no length of count. So a failed conversion sets it back to the value we started with at the very beginning of the two quotes. It gives you exactly that same thing. It gives you the nothing.
Okay. I'm assuming if input turns out to be a string, then it'll be a string.
Well, it is a string. It's always a string. It's a question of what the content of the string is.
Got it. Okay.
So it evaluates the content of the string as a J expression.
Well, that's what I mean. If the result of the J expression is a string, does J differentiate between when it comes to
I just realized something. I can actually put in any J expression that produces a number and it's going to work. So I can actually say 1 plus 2.
Because of the way that you've coded it.
Let's say run 1 plus 2. Oh. So any J expression, I mean, that's actually could be kind of valid. I enter an expression as long as I get a countdown value.
So you're taking input, which is obviously the X. Count is coming in on the Y. The left bracket, what does that mean in this case?
It says ignore the right argument. I don't care about X at all. It's not relevant.
Then why is it there?
Because J's interpreter gets really mad at me.
If you don't put X somewhere?
Because I provided an X to the left side.
So you got to dump it.
So I have to dump it. So
you got to dump it somewhere.
So the problem is, remember looking at power that X was optional? In this case, I include X. This is not an equals. I'm using input as an argument.
Yes,
the reason is because
X.
I need to show input.
This is that dynamic if with an X and a Y. So you're not checking to verify that it's a numeric value. You're just checking to verify that it doesn't come up empty.
That's where I screwed up.
Okay. The input equals period
because the input has a value here.
Yeah.
And
you had to clear the value there.
I have to clear it because the next thing I do is I ask for the countdown if it's cleared. Yeah. And I can't clear it before here because I need to show it.
That's going to continue until count has a value that you're looking for.
Yep.
In which case you're going to do your output again. That's another foreign world hello.
Yep. Without a new line. Yep.
You're taking your count. Now that thing, the minus space I period, is that not a fork, but is that the other one?
That's a hook.
A hook, right?
Yeah, it has two arguments. You could do it without.
What is the I period saying to do there?
Okay, so I period is equivalent to iota in APL, a range. This is something that Adam gave me. So if I bytes, this is what I did originally. Is I did this. I did 1 plus count, and I reversed it.
Okay.
And he showed me a way to shorten it. This is what I did originally. Give me a range from 0 to count minus 1. And because J is 0 based, I wanted it 1 based.
Well, if count was 5, you mean?
And then this reverses it and make it 5 to 1. He said there's a shortcut. You can apply the negative operator to this range and it will do both of those things.
Now, what is the ampersand period greater than?
Each. And in fact, in the wordy version, I use the word each. If you look at each in the standard library, it's equivalent to that.
So taking the Y value, okay, is that another fork?
That is
The
not a fork.
double quote colon Y is not a fork?
No, because if the right-hand side of that expression is a noun, it's not a fork.
Okay.
It's just a way of
So
isolating that value from being used, from being broken up and interpreted in different ways.
Okay, so you've got dot, dot, dot concatenated to Y, but we're applying a quote colon.
It looks like another glyph, but the fact that it's quote colon instead of quote dot makes it a totally different glyph. So they use the colon and the dot to expand the set of primitives.
What does the quote colon mean in this case?
Convert to string.
Convert to string, concatenate that.
Because you can't concatenate a number to a
And
string.
then output
Won't
that.
like that. So it's
And then ignore, okay. Then you output that and you say, okay, we're done with that statement. And then we just do a you sleep. All right. And then we do the bye-bye output, but then we have $.
Reshape. When it's monadic, it says, tell me the shape of something. When it's got a value on the left, it says, reshape this into that. If you reshape whatever you've got into a matrix of 0 by 0, it'll do nothing at all. This main procedure, the last expression is always treated as a result. And because the very last thing I do in here is execute main, when I run the script, it's going to output the result of main. So bye-bye would show up twice without that.
Got it.
I get the bye-bye that I output it. In fact, actually, I think I could just put bye-bye in there. Let's find out. I'm showing it to myself. I'm not showing it to anybody else.
I know. It's something you got to get used to.
Yeah. So there you go. Trimmed it down. Bunch of wasted stuff.
Good. That's nice. That makes more sense that way.
I output it and then said, don't output it.
All right. So then after that, so now I'm curious about that parenthesis down there at the bottom, because I noticed that there isn't any open of parenthesis.
Oh, that's the end of the main definition. So when you define, a verb, this is one of the multi-line things you get. This is all multiple sentences, and this marks the end of it. So there's no open paren, there's only a closed paren.
Are you identifying a call to main?
Yes. It's a
and
foreign
what's the
call.
Underscore?
Argument passed to main. It has to at least be monadic, and in order for it to be monadic, you just give it
I see. So it has to have, all right. So 9 bang colon 27 is telling you to execute main. And then after that, you're doing a 9 bang colon 29 to 1. Is that back to the keyboard again?
This I learned from a gentleman named Tangent Storm. We'll put a link to his thing. He's a heavy duty J guy. He's got his own YouTube channel and lots of stuff. And he was he's in the J on the APL forum. He's on the J Discord. And I was trying to figure out why this thing wasn't working properly and all this. And he's like, you got to do this. When you run it in the J console as a script, it starts to just kind of read all the text in. And it interprets while it reads, as it turns out. I didn't originally wrap this in a main function. I originally just had these as straight sentences on the left side. Sure. And it would read, and then it would execute, read, and execute. I mean, it does it in a single pass, read, execute. I think in that case, I would not have been able to define functions below because it wouldn't have seen them yet. So like when I broke it apart, the only reason that worked is because I didn't execute main till the end, till it had the chance to actually find everything. So even though I call the functions from main, I don't execute main until it's seen the functions. But I did that originally. What I kept finding was when I was going to input from the keyboard, I'd see source text showing up in the countdown. It would be going like that. I'm like, what's going on? You're asking for waiting for keyboard input, and the reader that's reading the source is using standard in to pull the source in. So what you have to do is you have to let it finish reading all the way to the end before you execute anything that does console input. If I hadn't done console input, it wouldn't have been a problem. Like if I had only done output, it would have been fine. But halfway through the program, I do input. It's still reading and using standard in. This is documented in the JWiki. Okay. There we go. Foreigns. 9. Globals. There we go. 29 and 27. 27 is, this is the thing you're going to do. 29 is wait until this happens and then do this.
Got it.
And the thing you're waiting for is the reader to be done. The reader has to get to the end of the script, which is the last thing that you've done, which is to tell it the thing, and now it does it.
Okay.
Gnarly, huh?
Gnarly is a word for it. Maybe J doesn't want to do bye bye hello world. Maybe
No.
it doesn't want to do this kind of code.
I would say
And
that's the
so,
case for all the array languages. We are
yeah.
rubbing up against some things that, like, this is not the use case for these languages. If you go in the J playground in the labs, they've got great examples. They're like, this is the sort of stuff people do with J, and this is how deep we can get, how sophisticated we can get. And it's like, yeah, that's great. And you're right, for the J audience, that's perfect. I was just thinking, I just want to say bye-bye to hello world for any language that has to do something simple that involves typical things that usually at some level you're going to be dealing with.
If somebody was forced to work in a J environment and they had to write something that did a lot of terminal input and output and a lot of user interaction, then yeah, bye bye hello. This is how you would do it. This is a
But the funny
it's
thing
not
is,
it's not something the language lends itself to.
but that's funny
this
when we
is how
say
you would do it.
that, because these languages are built on repls. And a REPL takes input and gives output and takes input and gives it. So the REPL itself does what bye bye hello world does, even though the person who's using the REPL is not writing a REPL. So
That's a good point.
at some level it fits, at some level it doesn't fit. J is a big language. You can program in a functional style, you can program in a procedural style. It's been around a long time, for decades. It's grown, and because it's grown, it's added a lot and it's taken away very little. And this is one of the trouble with older languages. Adam talked to this about needing to be careful with everything you add, because once somebody's got code on it, you know, unless you're going to break the world, you're married to whatever that thing is you did.
All of you out there, thank you for joining us once again.
I wish you at least the best of luck.